Charged pions decays to muons and anti-muon neutrino take the rest masses of the muon and a pion to be 105 MeV and 140 MeV respectively. The probability that the measurement of the muon spin along the direction of the momentum is positive is close to. This is one of the simplest questions asked in November 2020 CSIR-NET physical science paper. The reason for this is because there is neither any kind of calculation in this question nor the language of the question has been modified. Even in December 2019 paper conducted in Assam and Meghalaya, the question asked from particle physics has been repeated. This question is based on parity conservation. Let us first understand parity. Parity means mirror image. If parity is operated on a coordinate axis, then the axis of the coordinate is transformed into its mirror image, such as the x-axis in minus x-axis, y-axis in minus y-axis, and g-axis in minus g-axis. That is to say, parity operation transforms a right-handed coordinate to a left-handed coordinate. There are many physical quantities on which their sign changes under parity transformation, such as displacement. If a particle is displaced on the right side, then in its mirror image it will be seen moving toward the left side. In the same way, the momentum, acceleration, force changes their sign under parity transformation. But there are some quantities that remain invariant under parity transformation, such as angular momentum. Since both linear momentum and displacement changes their sign in parity transformation, hence angular momentum remains invariant. Similarly, spin is also invariant under parity transformation. But at subatomic level, there is an intrinsic behavior of parity, which is called helicity. Helicity refers to the orientation of spin with respect to the momentum of the particle. If the spin of the particle is in the direction of its momentum, it is called right-handed helicity. And if the spin of the particle is in the opposite direction of its momentum, it is called left-handed helicity. All subatomic particles in the nature are found to have both left and right-handed helicity, except neutrino. Till date, all neutrinos have been found left-handed helicity and all antineutrinos have been found right-handed helicity. Never found neutrino with a right-handed helicity or antineutrino with left-handed helicity. Now come back to given question. The charged pion decaying into charged muon and antineutrino. Since this is a decay reaction, the pion can be considered to be in the rest. If pion is in rest, its linear momentum will be 0, and pion is a meson particle of spin 0. That means the helicity of pion will be 0. But particles released from the decay of pion will not be in the rest position. Rather, to keep the linear momentum conserved, both these particles will release from the same momentum in opposite direction. As we know, till date all neutrinos have left-handed and antineutrinos have right-handed helicity. That means the helicity of muon antineutrino will also be right-handed. So, if neutrino is moving towards the left side, the direction of its spin will also be toward left side, so that it remains right-handed helicity. To conserve now helicity, the spin of the muon must also be in the direction of its motion. That means muon's spin and momentum will both in the same direction. So if the spin of the muon is measured in this decay reaction, then the spin of the muon will always be found in the direction of its momentum. That means 100% probability is that the spin of the muon is measured in the direction of its momentum.